So fill out all your givens, mark your diagrams, whatever you guys need to do. Okay, everyone see the proof statement. Proof TD congruent to RO. Those segments aren't going to be congruent unless the triangles. Okay, so now we got to make a class decision here, right? Because I want us to all do this the same way. There are two different pairs of triangles that contain TD and RO. Can we, as a class, decide which two we're going to try to prove congruent? Okay, because take a look. I could prove the top and the bottom one congruent, or I could prove the left and the right one congruent. Both of them contain TD and RO. Anybody have a preference? I do, but Evan? That's my preference right here. How about TDI and EDR? Or EOR, excuse me. EOR. So those two, the top and the bottom one. Yep, I like it. All right, we're going to find out pretty quickly why these proofs are going to be difficult today. Let's see what we have. What do you already know as far as sides and angles? Rachel, what do we already know? They're congruent because they are? All right angles are congruent. So we have at least a pair of angles. So angle TDI congruent to angle ROE. All right angles are congruent. All right, Rachel got us a pair of angles. Did I give you anything in the givens that would help you? Did I give you full sides? Any full sides in the givens? Yes. What sides? TI and ER. Yep. So I gave you a full pair of sides. So right now it doesn't look like this is going to be that bad because I gave you a pair of sides and Rachel just gave us a pair of angles with the right angles. Okay. Is there anything else you can tell me? Okay, Hugh, go ahead. You could, but is that a full side? Okay, so yes, you could, but I don't know how it's going to help. Okay, because OD is not a full side. Heaven. You could. Where are we going with this? You could, but the only thing I have marked are hypoteni, and I would need legs congruent. And I don't know how I'm going to get OR and TD congruent. I don't know how I'm going to get OE and DI congruent. See what I'm saying? HL means hypotenuse leg, right? And the only thing you have right now is the H. I don't know how you're going to get the L from there yet. Mike?
Could you say OR and TD are parallel?
You could. Where are we going to go with that, though? How are we going to use those? But that doesn't make them congruent.
Oh, yeah.
Parallel lines aren't congruent.
Oh, yeah.
Right? So you could say they're parallel, but they're not congruent. We're not picking up the hint yet, anybody, right? We're not picking up the hint. Emily? What do you need, though, to make them congruent? They are alternate interior, but what do I need to make them congruent? Do I have them? Nope. Okay, so that's out the window. Sure, go ahead, Kate. Okay, don't go there, please. Don't go there. I'm asking just right now. Have we figured out we can't do it? I think I've heard from like 5 different people. Are we all in agreement? It's no chance. You are not going to find me a third pair of anything unless you start making up stuff. Are we all in agreement? Okay, so this is why it's going to be tough today, because you cannot prove those triangles congruent as of right now. Step 3. You cannot do it. So what we need to do is we need to get over ourselves and say, forget about those triangles. Let's find another pair. All right, I'll get back to those eventually, but I'm not going to force it. There's no way, guys, and we just win. You guys proved it to me. There's no way we're proving those triangles congruent right now. So get over yourself and now find another pair that are congruent. And when I say another pair, it doesn't have to be with having TD and RO in it. Just find me another pair. That's what I need your help with right now. There are a pair of triangles in that diagram you can prove congruent right now. And I need you to find me those pair right now. Okay? Any pair. I don't care if they contain TD and RO. I don't care. I just want a pair of triangles congruent. Because I know I'm not doing these two right now. No chance. Impossible. Is there a pair up there, based on all this information and what you know, that I could prove congruent? And there is. Where are they? Where are they? Where is the pair? Where do you think, Rachel? Everyone hear that one? ETI? Find that one, locate it right now, and ERI, those two big suckers right on top of each other. Everyone see it? Why are they congruent? Well, I have 2 pairs of sides from the givens, and anybody see anything they share? Side EI is reflexive. So yes, Rachel, 100% correct that you can say triangle TEI is congruent to triangle. Let's see if I go TEI, I got to go RIE. Everything match up there? TERI, yep. Why are they congruent? Here we go. Now I'm going to turn it over to you guys. Why are they congruent? Here we go. 9, why are they congruent? What method? There we go. Now the question is, well, why did we prove them congruent? Did we just want to satisfy ourselves and say, hey, I proved a pair congruent? No. All right. We proved a pair for a reason. Because remember, we were off by 1 pair here, weren't we? Of congruent parts. We are off by 1 pair. Here's the tough part, but it connects the entire proof. In these 2 triangles we just proved congruent, can you find a full pair of angles or sides that are shared in the 2 triangles we need congruent? That's going to be the toughest part, but it connects the entire thing right now. So look on your diagram right now. In these 2 triangles we just proved congruent by side, side, side. Are there any corresponding angles or sides, full ones, that are also shared in these 2 triangles we almost got congruent? Look for it. Look for it. Look for it. I need a full pair of angles or sides that are shared in both pairs of triangles. It's there. It is there. Not partial angles, not partial sides, full ones. Find it, find it, find it. This is the toughest part of these proofs, are finding that common angle or side. So again, take a look at these 2 triangles. Find me a pair of angles or sides that are also contained in those 2. There. Sean, you ready to give it away? So, all right, hold on. Let me mark it. TIO, this one right here, everyone. That one right there. Everyone see that? They're in the 2 big ones we just proved, and they're in the ones that we need. My question is, why are they congruent, though? What makes those angles at step 5 congruent? And they're not alternate. We already went over with Emily. They're not alternate interior, so I can't say that. So why is angle TIE congruent to angle REI? How do I know they're congruent? And look at what we just did, Will. Aren't those corresponding parts in these two triangles? So if the triangles are congruent, so are the corresponding parts, CP, CTC. And that gives us our third and final pair of congruent parts to prove the two original ones. So now triangle, let's see, T, what is it, a DI, TDI? And again, make sure your corresponding parts match up. So if I go TDI, I got to go RDE. Oh, I did that again. The second time today I did it. Can't tell where the D and the O intersect here. ROE, thank you. Why? What method now? Everything's labeled up there for you. Boom, boom, boom. What's the method? Here we go. 7. What's the method? Nice job. Side is not in between. And now you can say TD and RO are congruent. By CPCTC. That's where we are today. You're going to prove a pair of triangles to get another pair congruent. That's where we are. This is as tough as it's going to get. Prove a pair to get a pair. Anything you want to ask up here? So be prepared today. I need these two triangles congruent, but you're not going to be able to do it unless you prove another pair congruent first. All right, I got one more to do with you before I let you take over in your groups. So mark what you got to mark. Highlight what you got to highlight. Okay. Don't call it impossible yet. Don't call it impossible yet. What do you know about those two triangles that I can count as full sides and full angles? Go through that first, because I got to know if I can do it now or how much is left. Hugh, what do I have? Okay, so you saw a common side, QE. I like it. So QE congruent to QE. Q has provided us with a full pair of sides. Did I give you anything? Did I give you anything that can count as angles or sides? Cameron? That's a full pair of angles, right? All right. So I need one more pair. Do you want me to go around to everybody and see again, or can anybody see anything? Please don't pull this. Oh, they look like they're right angles there, so I'm going to put some right angles. No, you're not. There's nothing there that says to put them there, so don't be embarrassing. Do you see the word bisector or midpoint? Please don't magically appear those words. All right, don't be a magician. Is there anything else I can do here? Nope, nothing else. I am one pair short once again. So get over yourself. Look at the diagram now as a whole. Are there any other triangles to prove congruent? Other than those two. We'll get back to them. We'll get back. Is there any other triangles up here that you could prove congruent right now? Emma, where are they? Yep, QTB and QUB, the two that are on top of each other. They're not congruent yet because I have 3 and 4 congruent and 1 and 2. Where's the other pair that makes them congruent? You got 2 pairs of angles here. Where's the other pair that makes these two congruent? Where's the other pair here, Luke? Oh, I thought you were. Go ahead.
For the 2 big triangles?
Yeah.
Okay, well, you can do QB.
Darn right you can. And you know what? I'm just going to, so I can save my shoulder a little bit here. QB congruent to QB, just put it in the second step. If you want to make a third step, To make yourself look a little smarter, make your proof a little longer, go ahead. Triangle, bless you, we're good. QTB, congruent to, if I go QTB, looks like I gotta go QUB. Anybody got a method they want to do? That's what I was thinking. Is that QB side in between the two angles? Yep. So angle, side, angle. All right, you guys, tough part right now. Tough part. Can you guys find me any angles or sides now that are shared between the two pairs of triangles? So look at the big triangle, two big ones we just proved congruent, and the yellow and the blue one I have highlighted up here. Are there any angles or full sides that are contained in both? Because that is the key to unlock this proof. Do you see any full sides or full angles that are contained in both pairs of triangles? Because they are there. Mike.
Side QT, side QU.
Everyone see that? QT and Q. In the big pair, check. And in the pair I need, check. So QT, congruent to QU. Why are those congruent? Because I proved the pair of the big triangles congruent, so those corresponding parts are congruent. And that gives us a side now. Do I have enough info to say the original triangles I needed are congruent? We all good? Need any more info, or are we good? We're pretty good. So now I can say triangle QET congruent to QEU, and just need one of the 5 methods. Side, angle, side. Doesn't look intimidating, 5 steps, but it's a lot of packed in there for 5 steps. Proving a pair of triangles congruent to get another pair congruent. All right. All right, here's your time now. Time to shine. All right, just take a look at the next proof. Before you get started, it is a 2-part proof. Please go in order. All right, please prove those triangles congruent first, and then prove GE congruent to GF. And I will let you know right away, you probably know this already, but GE congruent to GF is not going to be right after you prove the triangles congruent. Those aren't sides in the triangles I'm asking you to prove congruent. Okay? So go ahead, get after it. Everybody watching on the video, this is the entire proof when you get done with it. If you want to pause it right now and check it. Talking to myself.